Yep.
Okay, so hi everyone. I'm apologizing for the short delay, and it is my very great pleasure to introduce Professor Carey Morewedge. His research focuses on understanding decision making by humans and even algorithms. Professor Morewedge managed to publish in the very top journals, including Nature, Human Behavior Management Science, Psych Science, and many more, to name just a few. He was also chosen as 40 out under 40 most outstanding business school professors, won more than once various JCR awards, and perhaps what's most striking for me, he managed to develop two video games. Carey, now the floor is completely yours for the next 35 or 40 minutes.
Thank you so much for having me here and the lovely introduction. And I'm really sorry about the delay. I'm going to talk a little bit today about a set of different papers looking at when and why people distrust algorithms and whether or not this is really about um, something about algorithms or something about ourselves. So the work is very much a collaboration with several other folks. So Chiara, much of the work is with Chiara Longoni, who's a professor at Bocconi, Romain Cadario, who's a professor at Erasmus, Andrea Benetti at NYU, Begum Selaton, who's a doctoral student at Erasmus, Stuti Agarwal at a graduate student at Harvard Business School, and Julian DeFreitas at HBS as well. And the first part of the first part of the work is more with Chiara and Andrea, and then we'll get into some of the work with the other folks too. One possibility when we're thinking about people's willingness to use a new technology is that it's we can predict people's propensity to use a technology with some kind of formula, like we might with a BAS model, which is in marketing a typical kind of formula to try to understand how people will uptake different kinds of technologies, like a telephone or a refrigerator or electricity or other kinds of technologies. And these kinds of models in general tend to be reasonable at predicting sort of how new kinds of entrants to a market would diffuse and be their uptake. Um, but like algorithms tend to be a unique kind of technology in the sense that the typically when we're thinking about a new kind of television, for example, if we're thinking about how quickly will an 8K TV take over the market for 4K televisions, right? There's a clear sort of differentiation between the two, and they're relatively removed from ourselves. We're thinking about them as products. But in the case of algorithms, the the thing that they're replacing in many kinds of cases is not an old technology, it's a person. So for example, if we're in the context where um, we're doing skin cancer detection, the person that an algorithm may not be replacing another kind of technique for skin cancer detection, but rather be replacing the screening that a general practitioner might do before they send a patient to a dermatologist.
Sorry to interrupt you for a second.
Sure.
We all see part of your screen, so I assume you want to enlarge the presentation.
Sure. Can you see the whole thing now?
Yeah,
Okay, great.
thank you.
Okay, so in general, people do have preference. If we look at preferences for algorithms and people, algorithms and basic statistical models tend to outperform human judges in a variety of different kinds of domains. So there should be an appetite for algorithms, but people still tend to exhibit a reluctance to use algorithms, particularly when they err. And so we wanted to see sort of we have a meta-analysis that we're performing where we look at 156 studies and 67 papers, and we see that people seem to be more apt to be averse to the uptake of algorithms than to embrace algorithms on the whole. And but there are many kinds of exceptions, right? So people are using algorithms for many kinds of professional and personal contexts, from dating recommendations to finances and wine. So predicting sort of when people have these kinds of preferences between algorithms and persons is an important kind of task for us to do as a science. Just to give you sort of an example of the degree to which people may be embracing or rejecting algorithms, I think most of us would find that if we were in a hotel and we wanted to figure out how to get to the airport, we might be more trusting of an algorithm like Google Maps than we would a hotel concierge. But we're not willing to outsource everything to algorithms yet. And so there's some kinds of domains like a romantic partner, we would feel probably most of us would probably feel more apprehensive to have a romantic partner who's a chat bot than a living human. And so thinking about in which kinds of domains we want to accept and reject algorithms um, uh, is an important kind of task. I've looked at a lot of these kinds of issues in the context of medical artificial intelligence, which we define as any machine that uses any kind of algorithm or statistical model to perform perceptual, cognitive, and conversational functions typical of human minds, such as visual and speech recognition, reasoning, and problem solving. I think medical AI is an important kind of phenomenon to study. It's forecasted to become a $10 billion market by the end of the year, to pervade 90% of hospitals and replace 80% of what doctors currently do. It has a promise to deliver expert level accuracy and cost effective healthcare at scale, and is already effective for a variety of different kinds of diagnoses and triage applications. Medical AI is also really important to study, not only for the replacement kind of issue, but around the world, there are many kinds of populations that are underserved by practitioners, and so AI may be the only kind of healthcare that's available in those spaces. I study it from the consumer perspective because consumers directly determine the utilization of medical AI. So, for example, in the context of a application that is used to track skin cancer, consumers have to download the application and go through and input all of the kinds of data into the application to get their results. Excuse me. And you can see that the consumer use is being embraced by a variety of major players in the healthcare industry as well, and a major technology firm such as Google Health. Okay, so just as a brief overview of the talk, we'll look at when and why do we trust AI in the context of medical AI. Our first question is, are patients reluctant to utilize medical AI? Then is there a general prejudice towards algorithms? And then the third section will be looking at a new theory and some tests. And I'll skip over some of the studies, but if you have questions to dial down and look at some of the data, I'm happy to do that. Okay, so typically there's sort of two ways to look at this issue. So one is, what are people's preferences between human and AI providers? And another is their utilization of a human provider and their utilization of an AI provider. And so we look at both kinds of preferences. So how likely are people to utilize a human provider given no other option? How likely are people to utilize an AI provider given no option? And then how do we compare the two when they have a choice? In our very first study, that we brought participants into the laboratory. They were undergraduates who often report feeling stressed. We told them that we were going to take a measurement. We would offer them a measurement of their stress levels, which included a paper and pen survey, a cortisol sample, and this would be sent to the American Institute of Stress, which is a real organization that would provide them with some useful information about their stress levels and some kind of ways to mitigate stress. They were told in all conditions that the assessment consisted of a survey and then also from a salivary cortisol test, and they would get a chart, a qualitative assessment, and recommended courses of action to help manage the stress. The only thing that we changed between the two kinds of options were whether or not the data be analyzed by a computer or by a physician. And we gave them a performance benchmark so that they would not be thinking that there might be different levels of performance between the two. This was between subjects, and so people only saw that the analysis be performed by a physician or by a computer, and then we're holding constant the performance accuracy. When we ask people, would you like to sign up now for this assessment, we see that 40% are ready to make an appointment immediately when a human will analyze their data, whereas only 27% were willing to make an appointment initially when an AI was be analyzing their data. Next, we wanted to see sort of what the nature of this kind of algorithm aversion in the medical space is. Is it that people want no algorithms involved in their data? Like, if you could imagine, sort of a vegetarian would not want to eat steak at any price, right? Or is the nature of algorithm aversion more compensatory? So people are trading off the status of their physician or the provider as an AI against human, something like they might with price or accuracy or some other kind of component. And so we looked at this in 3 different studies with different samples in the context of healthcare prevention or disease prevention, diagnosis, and treatment based on existing technologies in use. So we also manipulated in these 3 studies whether or not the accuracy rate of the providers. So in one condition, the providers had equal accuracy or equal complication rates. In another condition, the one provider had higher accuracy than the other, and in a third condition, one provider had much higher accuracy than the other, or much lower complications for that service. And then what we manipulated here was whether both providers were human, provider X and Y were human, or whether or not one provider was a human and one was an algorithm, or the medical AI. And so by comparing the relative preferences between the human and human providers and the human and AI providers, we could see whether or not people are showing this non-compensatory decision rule where they just don't want any kind of medical AI involved in their healthcare, or a proportion of patients maybe may reject medical AI. And so that should be insensitive to accuracy. Or if people are thinking about the status of their provider as an AI, then they're going to be more sensitive to accuracy, but maybe that would incur a penalty. And so this is for the screening data. So this is from prevention. Here, what we see is when both providers are human in the black bar, and when they are equally accurate, people have no preference between the 2 providers. So that's just an attention check. We see when both providers are equally accurate, but the provider X is a human and provider Y is automated, people exhibit a stronger preference for provider X than provider Y. So the Y-axis is the relative preference between X, which is 1, and Y, which would be 7. So here we see evidence of algorithm aversion when humans and the algorithmic providers are similarly accurate. More important, what we see is that as the provider Y becomes more accurate, people prefer provider Y to provider X when both are human and when provider Y is a algorithm. But what we see is that the algorithm incurs the penalty relative to the human provider. So in other words, people are trading off the performance of providers for the status of one as being algorithms. And so it seems like people are using more of a compensatory decision rule when they're thinking about algorithm aversion than a non-compensatory decision rule. So people are thinking about the status of the provider as a price you could think of that they are paying when it's an algorithm that they may not pay when it's a human. And we see that too in the diagnosis study with different participants. These are all between subjects, each of these cells. And we also see it in the treatment study as well with different subjects, all between cells. And so the general pattern is pretty robust to the type of service being provided and the format as accuracy or complication rates. Okay, the next kind of question is, why is there a general prejudice towards algorithms, or do people show a specific kind of bias towards the kind of tasks that algorithms are doing? So if you think about in the context of medicine, there are different kinds of ways that algorithmic providers and human providers differ. So they have different training, they may use different kinds of inputs, they may different kinds of decisions, or they may communicate information differently. And what we think that the issue is really around the decision making. So people don't want algorithms to be making decisions, or don't feel as comfortable with algorithms making decisions as they would with a human provider. To test this kind of question, we ran a between subject study where we told participants that a nurse would take scans of their skin and would either send it to a dermatologist for a diagnosis, which their general practitioner would report to them. So here humans are analyzing, deciding, and communicating the information. They would send the scans to an AI for a diagnosis, which their general practitioner would report. Here the AI analyzes and decides, and there's a human communicating the information. And in the last case, they would send it to an AI for diagnosis, which their GP would use as an input for a final call and would report their data. So here the AI is analyzing, but there's a human supervising and making the final decision. And if we look at people's propensity to utilize this dermatological service, we see that people are more reticent to use it when the AI is deciding on their behalf, but they have no reticence when the AI is supporting a human decision. So it doesn't seem like people have a problem with algorithms involved in their healthcare. What they're really more concerned about is the decision being outsourced to an algorithm without human oversight. Okay, so then we look at sort of two kinds of ways or reasons why people might be more reticent for algorithms to make decisions on their behalf. Um, one idea is that while algorithms are likely to be able to take more information into account than a human decision maker, people may think that algorithms are more built for sort of an average patient, and people may think about their healthcare as being special. So generally, people view AI or algorithms as being more inflexible and unable to adapt to new and unexpected conditions in the environment. You could think about this from like the literature on actuarial and clinical kinds of judgment as that would be like the broken leg problem, where patients view themselves also as unique and different from others, even with respect to their diseases and health conditions. So you could say that I have like a cold, whereas you have the cold, right? And so my kind of situation is more unique. And so we explore the idea that this kind of uniqueness neglect, the idea that algorithms don't account for your unique health history and circumstances, or they're unable to do that, makes consumers more reluctant to utilize healthcare delivered by AI providers. So we use a scenario from Promberger and Barron where there's a recommendation to have coronary bypass surgery. We either tell people that a physician or an algorithm has analyzed the data and makes a recommendation that you should have the operation. In a control condition, we don't specify that the information or the analysis has been personalized to the patient. In the personalization condition, we tell them that they have personalized and tailored the data to the unique characteristics. And so what we see is if the care is not explicitly personalized, people are more likely to follow the recommendation from the human than the algorithmic provider. Whereas when the care is explicitly personalized, people should know difference in the two. To get again at this uniqueness neglect kind of idea, people tend to think of themselves as more individuated and different when they are thinking about their own health. They may think about themselves to be more individuated and different when they're thinking about their own health circumstances, whereas they may think about other patients as being more of a broad category or less unique. And so in another study, we looked at people's propensity to follow these recommendations made by a physician or an algorithm when the patient was you, when it was an individuated other person, or when it was an average patient. And so what we see here is that people are more likely to follow the recommendation of a human than an algorithmic provider when the patient is oneself or an individuated other, like you could think about it as like a friend or a family member. But people think that other patients on average should be equally likely to follow the recommendation of the human provider and the algorithm. So this is all between subjects again. So people seem to think the algorithms are fine for other patients, but not for themselves or the people they know. This is kind of an important kind of consideration to think of as you think of sort of the layers of healthcare, because doctors tend to think about patients at a more stereotyped, less individuated level. And so doctors may not be savvy to the idea that patients are reluctant to use these or rely on these algorithms unless they think about the context of the patient as an individual or for themselves, as may healthcare or health systems kinds of administrators or providers. The next phenomena that we looked at with regard to why people might not trust algorithms for decisions is that people simply don't understand the workings of algorithms. And so there's been some important work showing that the idea that AI is a black box inhibits adoption of AI, and that's certainly true in many kinds of contexts. Even the people who create algorithms aren't really sure about which parameters the algorithm chose or why it chose particular parameters rather than other parameters for its predictions, as there are like many kinds of correlations, and like that can be whether it's using one kind of parameter or another, maybe dependent on what kind of fold of training data an algorithm was trained on. But a lot of work has shown that human thinking is also a black box. So early work by Nisbet and Wilson, for example, showed that people believe that they have insight into their decisions. So they would show people four pairs of hose, and they would ask them which they preferred, and most people prefer the last pair. But when they ask people to explain their decisions, people don't have insight to the order effect that's there driving their decisions. They tend to think about sort of differences in quality, even though these were identical articles of clothing. And so we think that this idea that we better understand human decisions than algorithmic decisions may drive algorithm aversion. And this is sort of built on the idea of the illusion of explanatory depth. When we think of causal systems in the world around us, we believe ourselves to have like a deep understanding of how they work. So for you, if you ask people, how well do you understand how a helicopter works? People might report that they have this kind of level of understanding. But when you ask people how a helicopter works, they basically just to draw or explain how a helicopter works, they basically say it has like rotors that spin and it goes up, right? And so if you you can get people to recognize the degree to which this understanding of something is illusory by asking them to explain it. We test this idea in the context of skin cancer detection with nationally representative samples, and all the studies in this package are pre-registered. In one study, we initially looked at whether or not people show a larger illusion of explanatory depth for human providers than for algorithmic providers, where we asked people to think about a scenario in which they would get a scan of a mole, which would be analyzed by a doctor who would give them some kind of risk assessment for the degree to which the risk of it being cancerous, or an algorithm would create an assessment, and then they would give an assessment of the degree to which it would be a cancer risk. And so what we did in this study was we used a traditional method in this literature to try to show people the extent of their lack of knowledge about how these decisions are made. And so first people reported their subjective understanding of how a doctor or algorithm examines scans of their skin to identify cancerous lesions. Then we prompt people to explain how that's done. And so the idea being here that if people think that algorithms are a black box, people will recognize in advance that they didn't understand that. And so that won't change their perspective on their understanding. Whereas if people believe that they understand how a doctor makes these decisions, this should reduce their confidence in their understanding of how the doctor makes the decision. And then they report their subjective understanding afterwards. And so we're measuring this change from pre to post to see the degree to which people are exhibiting an illusion of explanatory depth. And we also control in all these studies for people's perceived risk of skin cancer, how often they examine themselves, and the perceived efficacy of self-examination, and those factors don't change anything. Okay, so on the y-axis are people's subjective understanding of how the medical decision is being made. In the white bars are the reports of their subjective understanding before the explanation. In the gray bars after the explanation. And what you can see here is that asking people to explain how their doctor makes a decision is reducing their subjective understanding of that medical decision. So people overestimated how well they knew what their doctor was doing. But in the case of the algorithm, people don't change their subjective understanding before or after they're asked to explain. And you can see that people report a lower subjective understanding for algorithms than for the human doctor, even after we pierce this illusion of explanatory depth. As a robustness check, we also tested whether or not people really don't understand algorithms and human medical decisions to the same extent, or whether or not people actually understand human medical decisions better than algorithms. And so we tested either participants' subjective understanding or their actual objective understanding of how algorithms and dermatologists make these decisions. And so we worked with a team of dermatologists at Erasmus who had worked on skin vision to develop a measure of testing people's knowledge of how dermatologists make this decision and how the algorithm makes the decision. And so what we did here was in the conditions in which people reported their subjective understanding, we see that people believe that they better understand how a human makes the decision than an algorithm. Whereas in the conditions for objective understanding, we see that people are equally bad at reporting how a human doctor would make the decision as an algorithm. And just as a side note, people are at chance for both. So the short answer, sort of a takeaway here, is that people have no idea how their doctor is making this decision about whether or not their moles are showing a risk for skin cancer. just as they have no idea for how the algorithm is making the decision, but people believe that they understand how their human doctor is making the decision, um, and they don't believe that they understand how the algorithm is making the decision. Then what we tried to do was in 2 intervention studies, we tried to see if we could boost people's perceived subjective understanding of how these decisions were made by humans or algorithms, whether we could um, reduce that kind of gap and also see downstream effects on the propensity to use medical algorithms for these kinds of problems. And so the human doctor typically will look at a mole according to its asymmetry, border, color, and diameter. And so we told participants in this sort of ABCD intervention that humans and algorithms use the same kind of parameters to make these kinds of decisions. And then we looked at their subjective understanding and their utilization. So some participants were exposed to this intervention where they learned about this. Other participants did not receive this information. And so the control condition, again, so we replicate that people report greater subjective understanding from the human medical provider's decision than from the algorithm. In the intervention condition, we reduce this gap. And then what we see downstream in terms of utilization intentions is that people are more likely to utilize the human provider than the algorithm in the control condition, whereas we see that gap declines in the intervention condition. And we see that this change in subjective understanding on the left is what's driving the change in usage intentions on the right. So here's the moderated mediation. We also replicate it with similarity intervention, which is based on how the algorithm is actually make the decisions in terms of just sort of matching pixel similarity, and that works too. And then we want to see sort of how useful is this in practice. So we did a Google search ad study with 14,000 impressions where we used in the control condition just the existing ad for Skin Vision, and we advertised it as a skin cancer detection app. And it just says our algorithm checks if skin moles are cancerous moles, take pictures of your skin, and get a skin cancer risk assessment. And as a treatment condition, we pre-tested an intervention to see whether or not it would give people a greater sense of subjective understanding. And the intervention ad that we showed was it basically just explains how the app works. It checks mole shape, size, and color. So our algorithm checks how similar skin moles are in shape, size, color to cancerous moles. You take pictures and get a skin cancer risk assessment. And so what we see is it like almost doubles the click-through rates per impression. And so the search terms we use were like pretty specific in this case. So the click-through rates are very high, but it's basically like skin cancer test or is my mole cancerous, like that kind of thing. But we do see in the click-through rates that this intervention simply explaining how the algorithm works almost doubles the odds that people will click through to the Google store to download the app, or to at least investigate the algorithm. Okay, so we see consumers are reluctant to utilize medical artificial intelligence. They're less likely to utilize than similar human providers. They're willing to sacrifice performance to see a human, and this reluctance seems to be compensatory. We also see this is due more to biased perceptions of humans than to biased perceptions of algorithms. It's more for me and my unique health history, but not for other patients. And it's driven by a biased belief that I understand how my human doctor is making a decision, whereas I believe I don't understand how well the algorithm's making the decision. Okay, how much time do I have left for the talk?
Good question. Depends on how much time do you want to leave for the questions in the formal part. Like we have to end the formal part in 12 minutes.
Okay, so let me just present a general theory, and then we can do questions. Okay, so in general, I think when we're trying to predict about when people show this kind of bias towards algorithms, we can look at the literature from social cognition on how people compare themselves to other people. So algorithms are doing many of the kinds of tasks that other people do or they would do. And so we can think about these kinds of biases as aligning generally in the way that we think about other people. And so if we looked at the cases in which people show biased social comparison, where they're evaluating themselves in a biased fashion relative to other people, or they show these kinds of biases of self versus other, that those tend to be in cases or tasks or skills or domains that are important to their self-concept. So like they're identity relevant. And also these biasocial comparisons are exhibited more when there's an ambiguity of evaluation. So you need to have some latitude for bias to influence an evaluation. And so I proposed sort of a framework for thinking about this where we could look at cases in the top right corner where people prefer humans to algorithms as tasks that tend to be more identity relevant, but also more ambiguous in their evaluation. Cases where people prefer algorithms to humans are cases that are less identity relevant, that have less ambiguity in terms of their evaluation. And then there's some really nice data from Eugenia Leung and Gabriele Pelocci and Stefano Puantoni, where they look at tasks that some people identify and don't, like baking or biking or cooking or driving or fishing. And if people identify with those things, they don't want them to be outsourced to an algorithm or automation. And if they don't identify with those, then they're happy to do something like buy an automatic bread maker or have a self-driving car. And so this basic framework suggests that biased evaluations of algorithms should echo biased evaluations of other people. And some of the more recent work I've been doing has like looking at this too. So we compare people's preferences, for example. There's a long literature on better than average effects where people tend to think of themselves as being better than average drivers or better than average at using things like a computer mouse. And so we find if we ask people to what extent would you like your car to be automated and give them different levels of automation, we find that people prefer to have less automated cars for themselves than for other people. And this is because that people think that relative to an automated vehicle, they are a better driver relative to the automated vehicle, whereas other drivers are about as good as the automated vehicle in terms of how trustworthy and how safe they are. And that predicts their automation preferences. So the difference which with people are assessing themselves and other people is influencing their preferences for an AI or a self-driving car in this kind of situation. And we see that this sort of greater trust in self and the greater safety of self relative to AV versus like others relative to AVs are driving their preferences for automated vehicles. And this is not about sort of the just differences in relativity. We also look at this trust in self versus other and the trust in the AVs. And so people don't differ in terms of their trust in the automated vehicles and the self or other condition, but they do differ in terms of their trust of the human driver in the self versus other condition. We also have been looking at this kind of theory in the context of where evaluations of algorithms trained on self should echo evaluations of other people. And so we've been doing this in the context of bias detection. So people tend to see more bias in others' decisions than in their own decisions. This is the bias blind spot. And so this predicts that people should see more of their biases in decisions made by algorithms than in their own decisions. And so the basic paradigm, what we have here is that we have training data where people are rating a set of targets like hosts on Airbnb or drivers on a rideshare platform, and they're given some diagnostic attributes. And then we include a biasing attribute like gender, race, or the attractiveness of the host or driver. And then they or an algorithm rates a second set. That's either the algorithm's either trained on their ratings from set A, or they make ratings from set B. And then we ask people how biased are the judgments of the self or algorithm, or we tell them that the ratings from set B are made by another person or by an algorithm trained on another person, even though it's all their own ratings or they're an algorithm trained on their ratings. So just to give you an example of what this kind of paradigm looks like, this is an example from a rideshare paradigm. So we'd ask people, how likely do you think this person is to be a skilled driver? And they're given some information about the trips, star rating, their experience, and the car. That's all randomly generated from a pool of options. And then what we're manipulating here is their gender. And we also do studies where we manipulate the race of hosts and randomly assign them to different kinds of star ratings and ask people how likely they would be to rent, uh, and they measure their rental likelihoods of the apartments. And so what we would ask people to do in the situation is we would show people a summary afterwards of all the judgments. And so we're asking them, how biased are these judgments? How likely are these judgments to be influenced by the race of the host name, and compare their perception of bias between self and an algorithm trained on themselves, or between self and other people, and self and an algorithm trained on other people. And so in a first study, we give people 16 Airbnb listings. We give them descriptions of the homes, star ratings, the host names, and then we ask them their likelihood of renting. And then what we do is we do a couple of different kinds of scenarios. We compare their perceived racial bias when we show them their own ratings from phase B. We ask them how biased are the ratings of an algorithm when we show them their own ratings from phase B. And then we build a real algorithm that predicts the ratings based on their phase A training data, or both of their judgments from phase A and phase B, or just from phase A. So in this case, the real algorithm is using their data to make a prediction, and they're judging the bias in that algorithm. And basically what you see is that people perceive themselves to be less influenced by the race of the host when they're told the ratings are ones that they made themselves, than when they see the identical ratings that they made, but it's attributed to an algorithm, or when the ratings actually made by an algorithm that's trained on their data from phase A, or phase A and phase B. And we see this in the case of the rideshare drivers too, and look at age bias. So people perceive themselves to be more influenced by the age of the driver when they're told their ratings are made by themselves than by an algorithm, whether that algorithm is actually their own ratings in the self-trained algorithm condition, or is a real algorithm trained on their data. We also see that algorithms, people show the same kinds of beliefs that they see biases in algorithms trained on other people, and they see that kind of bias in other people's direct ratings. So what we see here is that like algorithms kind of remove this bias blind spot in a sense, because people see their own biases better when they're reflected in an algorithm than in themselves. And I think like a pragmatic kind of way of thinking about this is like, you can see like how bad your taste in movies is when you look at your Netflix recommendations, right? In a way that like would be difficult to observe when you are just choosing your own movies. Okay, so I'll skip just so we have some time. We also see that people are more willing to correct their own biases in the case where people are told that the data is like an algorithm trained on their data than in their own ratings. Okay. Okay, so in general, it seems that algorithm acceptance is not driven by a general prejudice towards algorithms. It's driven and predicted by self-serving biases and comparisons between algorithms and self. I think this theory is like interesting because it opens new directions for research and advice for practitioners. So one possibility is we can work on the identity front of these issues. So we can reduce the identity relevance of tasks. So if you're trying to get doctors to think about using an algorithm, you could have them think about the algorithm replacing sort of more routine or less important kinds of aspects of their work. Just as we have no problem using statistical packages to do our analyses, right? We could present algorithms as supporting, not replacing human judgments, and frame as for others, not for self. And you can see that in a lot of like the voice assistants are asking, what can I help you with, rather what can I do? And then in the other kind of case that we can work on increasing algorithm acceptance, we can explain how performance is evaluated. We can show objective differences in explaining how algorithms work. And you can see even OpenAI is using these kinds of techniques to try to get people to understand how like models like ChatGPT are trained to increase acceptance of them. Okay, I'm sorry to start late. And thank you very much for your attention. And if you have any questions, I'd be delighted to stick around and answer them.
Thank you. That was fascinating. This was super interesting. I think we have time for one question now, and then we will move to the informal part, and those who want to ask questions there can do it. So, wants to be the first?
Hmm.
Unless we have,
Should I ask a question since I work in
yes,
healthcare? So Kerry, I think like healthcare. It looks like when you shot them up with the identity focus, and it seems that healthcare can map everywhere there because there are so many different instances in healthcare.
Sure.
So cancer diagnosis is only one of them. So I wonder if what are your broader thoughts about that? Because I have studies of my own that I find completely different results when talking about talking to a chatbot as opposed to cancer diagnosis, still using AI versus human.
Yeah, I mean, I think the framework is trying to help us predict based on how people are thinking about these kinds of issues. Like, to what extent is this something relevant to like myself versus less relevant to my sense of self? And then to what degree is this like an objective versus a subjective decision? So, how much like can you give people more precision in like how well the human and the algorithm are presenting? So, um, like here's an example. Like people might be more reticent to use a chatbot for mental health, right? Which because they could think about that as being sort of more subjective than for using like a chatbot about triage, about like whether to come in for like Lyme disease if they've been bitten by a tick. So even in the kind of technology that they're using, like whether or not people think that judgment is more how like what's the precision on that judgment, or how easy is it to articulate and put like quantify, um is that more of a qualitative or a quantitative decision that could be that sort of around the ambiguity kind of issue. And then you could also think about like mental health might be more relevant to like identity than something about whether or not like I have COVID, or whether or not like I have some other kind of thing that's not like essential to the kind of person that I am. I think there's some really interesting work too with like the chatbot kind of issues too that some people have started looking at around like stigmatized kinds of issues. So I've been looking at this issue from like the concept of like replacement, or people's belief that their data is being considered, but there are probably some cases where people would not want to interact with a human due to like the judgment of that. And so I could certainly see in like the chatbot kind of space that people might prefer a chatbot for things that could be like embarrassing, for example, like a sexually transmitted disease, or like accidental kind of pregnancy kind of issue. So like that, there's certainly sort of issues around like identity there that could lead people to be more accepting of algorithms if they're worried about how other humans would judge them. Does that?
Yeah. I know there's like an opposite bias. Maybe it's an unrelated bias that people don't like talking to humans anymore. Maybe it's also because of AI, but there are many cases, like smoking cessation used to be, you could call and someone's going to help you. But now if you ask smokers, do they want to talk to someone to help you quit smoking? They said absolutely not. Like, send me text messages, let me talk to AI chatbot, but definitely I don't want to talk to a human. I don't know if it's because of stigma
Yeah.
or other aspects, um, but that's maybe why, because of the algorithmic world we're living in, it affects
Yeah.
everything.
I mean, I think it's like one of the take homes is that it's really sort of a compensatory thing. And so here's an example. So I'm giving you the Google Map example, right? So you're at the hotel, you're trying to figure out how to get to like, let's say a restaurant, right? And so a concierge could tell you how to go there, or Google Maps could tell you how to go there. If the concierge like would say, "Hell, I'll just walk you to the restaurant," you might prefer the concierge if they don't talk a lot, right? But like if you Google Maps is there with you, right? And so there's like more information there too. So you could think about it as like the algorithm, like the status of it being an algorithm, all else equal, takes a hit. But there are certainly other kinds of factors that people might care more about, like convenience or price or speed, that they're willing to trade off for that. And so I think especially in the healthcare space, that's a very useful thing to think about, where if I can get test results overnight from an algorithm, I'd rather have that like immediately if I like very anxious about like some kind of medical diagnosis, whereas like, or if it's more convenient, like I might be able to do the thing at home instead of going into the doctor's office. In those kinds of cases, whether or not, and it's an algorithm, matters less than like how fast I can get the analysis performed.
Thank you very much.
Thanks.
Now the formal part is over. Again, thank you for coming despite being sick, and feel better soon. And now we'll move to the informal part, and those who want to stay with us are more than welcome to do so. And those who have to go can leave now.
Carey, can I ask a question?
Sure.
I wondered, I'm not sure that I followed all the results that you presented, but I wondered some of them might be not human versus algorithm, but rather familiar versus unfamiliar in a way. So, so for example, in the doctor example, you can think about, let's say that there is an algorithm that I use already, and now there is a new one. So you'll probably get the same thing, right? People do not trust or will not be able, you think that they are not able to explain, although they also can't explain the current algorithm, right?
Yeah.
So
I mean, I think familiarity is like something that we've studied, and that is a strong predictor of like how positive people's evaluations are of like a variety of different kinds of things. Like you can think about like the old science work on the familiarity of like even polygons, right? Like people prefer random polygons that they've seen before to new polygons, right? Suzanne Shu and colleagues have a really interesting paper looking at the normativity, like if they think the norm is to use an algorithm, then they're more accepting of the algorithm than if they think the norm is to use a human, right? So I think these are all other kinds of factors, right? And so we can look at, there's a variety of different kinds of factors and parameters that are going to shift these decisions around. I think it's very useful once we think about this distinction as being like a compensatory decision rule, right? So just as like I might be willing to pay more for a car with better gas mileage, right? Like, so we could think about like algorithms are like something being an algorithm is like a price, right? And so in many kinds of cases, like that price is traded off against these other kinds of dimensions. So like, you know, we know as psychologists that familiarity is something that makes people more comfortable with something. And so I mean, I think you're pointing out something really interesting. So if you look at the original Dietvorst paper from 2015, they use GPS as an example where people would not want an algorithm, right? Like that, you know, now even if you tell me how to get to the airport, I'm still looking at Google Maps, right? So,
exactly.
There's certainly changes in our culture or in our familiarity or our habits, right, that are going to disrupt that. And like just the convenience of using these kinds of technologies is so incredible. Like, I can tell you, can all of these kinds of factors can lead to preferences for algorithms, like familiarity, convenience, like exposure, those kinds of things. So, but we do see that when we're trying to control for these kinds of things, people they're still thinking about that from like a negative perspective if it's something relevant to their identity. And so I think you can see there's places where people are not using algorithms. Like, so a lot of consulting firms, for example, or coding firms are trying to get people to use like LLMs to like save tremendous time in terms of like computer programming tasks or other kinds of things. I have a friend who has like a medical startup, and he doesn't even need to hire programmers anymore because he can just outsource everything to LLMs. But people are still like not using these technologies as much in the workplace as their employers would like to be using them. And so, these are all sort of like, there are factors that we know in general about technology. So I would say if we go back to that first graph, looking at these like BAS models, there are things that we can predict about any kind of technology. But what I think is interesting to look at is like how algorithms are unique from the perspective of differing from other kinds of technologies and predicting their adoption. And so the places where people will be more reticent to adopt them are cases in which they feel like they're like things that are important to them are being replaced about themselves. And there's enough like ambiguity there for them to come up with a way that's that like they're better than the algorithm or like they're.
But in a way, the compensatory process that you're speaking, the cost you can talk about it more broadly, about a new thing
Yeah.
that is not familiar to you. There is some kind of cost for that, and right? So
Yeah, I
yeah, I
mean,
understand what you're saying. I
yeah.
agree.
Yeah, there's people are reticent to take up any kind of new technology, right? Like there's an adoption curve. So you could think about electric vehicles or like
Mhm.
Bluetooth or smartphones or even like TikTok, right? And so there are formulas we can use where we look at typically like how innovative is the thing and like what's the social pressure to use the product, like what are the network effects. And so those are really good at helping predict uptake. But the question I've been trying to push here are algorithms just like those other kinds of technologies are just new things that we are need time to like familiarize ourselves with? Or can we say like there are domains in which we're like less likely to uptake algorithms as quickly than other domains? And so I think we can use this kind of idea of like identity threat as a way to make predictions about in what domains might people be slower to like take up algorithms than in other domains.
Thank
Yeah.
you.
Go ahead.
Yeah, I just want to add that it's nice that your last point clarifies the relationship between your research to the paper we presented last week at Spudam, and that you say that familiarity might be important, and what Tori shows that not under all conditions familiarity has this effect, that in some situation actually familiarity can lead people to prefer human over algorithm, and also what he suggests that algorithm can use this trick once they understand when people learn to love them, then they are going to be biased in a way that people will like them. That is a really nice continuation, and this is one of the idea behind this seminar, to make sure that we clarify the relationship between different projects. So that was
Yeah.
really nice.
Well, I'd love to see that paper if you'd be so kind as to send it to me.
Unfortunately, I'm not a co-author, but it's a nice paper.
Okay.
Following the,
Can I ask also?
go ahead.
I want to whether you did any study about behavioral change. For example, eating behaviors, sleeping pattern, physical activity, and things like that. If with that people will believe, if they know that the algorithm is based on, for example, cognitive behavior therapy or motivational interviewing, as I understand from what you speak, is that it's very important to explain how the algorithm is based on. That people will believe more if they know that it's based on cognitive behavior therapy or something like that that is proven to be efficient.
Yeah.
But how do people behave to behavioral change? Not really psychology treatment, but mainly things that people have to do every day, like physical activities, stop smoking, sleeping better, things like that.
That's a great question. I've been focusing more on acceptance of the technology. But like the questions about like, adherence, and I think is it Michael or Mikhail was talking a little bit about like the text message, like I'd rather have like the text messaging than I would talking to like getting like here's an example. Your mom could call you every day and tell you not to smoke, right? Or you could get a text message reminder not to smoke. I think most people prefer to get the text message, right? So it might be less effective, but like it'd be more pleasurable, right? So you could think about like there are definitely like really interesting adherence kinds of questions to study. I myself have not been looking at like the question of like how likely are people to how likely is the algorithm to change their behavior. We do have some data I can show you more carefully. Let me see. Let me see if I can find the. So in the PNAS paper, what we do is we not only look at people's propensity to see bias in algorithms, which they're better able to do, but we also look at correction. And I think this is important for like medical kinds of contexts, but it's also like important around like alignment and training of algorithms in general to like see human bias in algorithms. And so here what we do is we show them 18 rideshare drivers. They get some like diagnostic information. They also get like, we manipulate, these are faces from a database that Alexander Todorov and colleagues developed. And the faces are rated on a variety of different kinds of dimensions. And one thing that we manipulate is the attractiveness of the driver. And so we tell people that we tell them about the beauty premium and that people tend to be more trusting or show a halo effect for more attractive individuals than less attractive individuals. And so we showed them the ratings of the drivers that they made, or the ratings of an algorithm trained on their ratings. And then we asked them, here was the rating of the algorithm, or here was your rating, right? 31 on the bottom. Feel free to change the evaluation if you think it was influenced by this bias, right? So, and then we look at like what's their raw change in terms of how much correction do they do. So if we look at like the perceived bias, which is the violin plot on the left, people see more bias in the algorithm than in their own ratings. And if we look at the raw correction, we see that people are engaging in more raw correction of the ratings when they're attributed to algorithms than to self. And so we see that the difference in perceived influence leads to this change in correction. And so we see overall, if we look at how actually biased the ratings are by attractiveness bias, we see that there's like an actual change that's predicted, like that's greater for the self and algorithm through this path. So I don't have data for you on, the propensity for algorithms to change other kinds of behavior, but we can certainly see that people seem to be more amenable to correcting bias when it's attributed to an algorithm, even if they're told to train on your data than on themselves. And there's other kinds of directions that would be really interesting to look at too. So Nathan and John Kleinberg and some colleagues have been really looking at other ways that algorithms help people engage in behavioral change. And if you think about like early like self-control theory, like I think it was like the cybernetic model of self-control, people need to have monitoring in order to enact change. And so in many kinds of cases, like algorithms are simply like aggregating data and giving people like information that they didn't have before. So for example, like when Google built an algorithm that analyzed its HR practices and then started like making predictions for candidates, and people saw like profound gender bias in that system. So if someone went to a women's college, for example, they would get docked relative to like a less specific kind of school. People started to like the algorithm was biased, but it was biased because their HR decisions had been biased. And so like Google's solution was to like delete the algorithm, but like what the algorithm is just telling them is like how like there is bias that's there. So if you look at your like health data, it can probably, people may be more, my work suggests that like with Romain and Begum suggests that like people may be more willing to see sort of biases or things that are less savory in their behavior if it's projected in an algorithm than like if they have to look at their behavior directly, right? This other work is suggesting that like algorithms may provide that like, sort of basic monitoring that you need to be able to enact behavioral change. So people have to have some kind of like handle on like what they're doing or what their patterns are, and the algorithms may be able to do that in a way that they would not from memory or would not otherwise like aggregate.
Thank you.
Thanks.
Thank you.
Hello, can I ask a question?
Sure.
Yes, go ahead.
Yeah. Okay, thank you. So I was, well, thank you for a great talk. I was looking, I think it was already a few months, just high level on whether explainable AI, as you said, opening up the black box, making the decisions more understandable, or and how or why algorithms make a decision actually reduces or increases, its effect on algorithm awareness and AI trust. And it was all over the place. I mean, some studies showed that it did improve it, some showed that it did absolutely nothing, and some even showed that it was worse. So I'm just wondering, based on your work and your research, what your thoughts are on. I don't remember, there weren't any consistencies on like applications or trends around that. I was trying to find, when does explainability work and when doesn't it? But yeah, just curious based on kind of your work, what your thoughts are, maybe to help me move forward with that question.
Yeah, I mean, the explainable AI issue is certainly relevant to this work. So this work suggests in general that like how if people understand how the algorithm is making a decision, they feel like they have a greater subjective understanding of that, and so that should increase their utilization. Um, Explainable AI too, I think could like decrease utilization if people think that like the validity of like the claim, like the data is more suspect, right? So there's like I haven't looked at like the content feature of like what is the content of the explanation. We don't see a difference between the two kinds of techniques or interventions, like in terms of their um, in both cases, like explaining how a doctor or how the AI is making decisions about skin cancer assessments is like increasing understanding and utilization. But certainly people thought that like when you explain how these kinds of things are making decisions, if people don't feel like that's like valid criteria, that certainly would or if they're further confused by that too, right?
Yeah,
Then
yeah,
that those are both kinds of directions where you think that
yeah.
like explaining AI might um, decrease use.
All right, thank you.
Thanks.
This is a super interesting presentation. I have to admit, this is perhaps the first time that we have so many people staying for the informal discussion. I might perhaps ask the last question before we leave, because I'm very curious. You mentioned before that when programmers are, if I understand correctly, that when programmers are asked, they don't use the GPT enough. So I think the same problem I encounter with my students when they submit their homeworks, they also never use the GPT. At least this is what they claim. So my question is, whatever this is just what the programmers claim, not to use the AI because they are afraid that otherwise they will be just fired because they're useless if they use all the time the AI. So do we have to trust them in this sense?
Yeah, I mean, I like the question about, I think there's sort of two questions there, right? Like, do we in the workplace, like how much monitoring do you want to do of people to use algorithms when it's beneficial to their work? And so you could think about even your doctoral students, right? If they use like a GPT to like code their analyses, it's going to be much faster than if they were to do stuff like just writing that by hand. And so, but they also have to understand like when it's making mistakes. But if you go to the Psychology of Technology is like a really interesting conference. They had you know, like folks from major consultancies where they're saying that we can do like basically like a month of work in a day or two if people are using these GPTs. And so, if you look at like interviews with like Mark Zuckerberg, for example, too, they're predicting these like wide swaths of unemployment for like early level and mid-level programmers. And the idea being that the people who are going to be using these algorithms will be the ones who are doing incredible amounts of work. And the people who don't use the algorithms, like that usage will become very distinct in terms of the output of people, the output of employees. And so I think when you get to we're in this sort of liminal space right now where like there's not such a clear distinction. So for example, if I put in like basic business cases into ChatGPT and ask it to solve them, like Carter racing, it still shows confirmation bias. So if you ask it like whether or not to race or not race, and you ask it like is temperature like an issue in this case, right now ChatGPT like doesn't think temperature is an issue, when that's like sort of the crux of the case. And it shows that same kind of confirmation bias that like NASA engineers did in like so that it's harder to like do that distinction now, but like I think over time, um, as people figure out how to use these algorithms, then we'll see that kind of distinction. So I do see a lot in my MBA classes, like there's like usually like a third of the responses, like a third of the case write-ups, like in the early stages of ChatGPT were very similar and like wrong in the same way. So, yeah, I don't, I'm not sure like what the optimal answer is there right now. I think as academics too, we're like thinking about that problem in our work a lot. If you have suggestions on how to encourage or discourage that kind of use, I'm all ears.
Unfortunately not. I'm not smart enough yet to make suggestions. But maybe when Ori publish his very interesting talk from the Spudeb conference, maybe then we will learn something new. This was a kind of a joke because I'm also pleased to be a co-author on this one. Anyways, this was a very interesting presentation. Thank you very, very much. And you will definitely hear from me more.
Great.
And feel well.
Thank
And,
you. Thank you,
have a
everyone.
nice- Yes.
Okay.
Bye.
Have a good day.
Take care.
Bye.
Bye.